Hello everyone, welcome back to my YouTube channel. In the previous video, we studied about time series forecasting where we studied moving average, exponential smoothing, seasonal variation. Now today we'll be starting with production. What is production? Production is the transformation of factor inputs, that is land, labor, capital, and entrepreneur into goods and services. This is what is production. Production means presenting tangible and intangible goods for sale. It can be either tangible or it can be intangible. Transforming input to output. Input to output. Creating value. Creating value. Characteristics of goods and services to be classified as production are created by human labor and capital. They satisfy the human wants directly or indirectly, are comparatively scarce and have economic value, have definite monetary price or cost. Let's write this. Characteristics. First is created by labor and capital. L stands for labor and K stands for capital. Satisfy human wants directly or indirectly. Indirectly means as raw material and directly means as the finished product. Then scarce and have a economic value to it. And fourth point, that it has definite monetary price or cost. Next, let's see the factors of production. We classify inputs as land, labor, capital, enterprise. Let's see land. Land is something that is immobile. It is passive and it is heterogeneous. Let's write this: immobile, passive, heterogeneous. Labor. Labor is active. Labor is mobile. Mobile means some movement is there. It is variable. Sometimes we need more labor, sometimes less. And productivity can vary based on labor. Capital. Capital contains structures, equipment you want to use, capital goods, and money. Enterprise contains innovative function. There is always a risk involved and sometimes decision making has to be done. These are the four factors of production. We'll write the heading here: factors of production. Now, a production function can be written as Q. Production function can be written in the form of Q. that a firm can produce specified combinations of inputs where tech is constant always. Like we assume that the past data is constant, here we are assuming that your technology is constant and your output is a function of your labor and your capital. Assuming that the firm produces only one type of output with two inputs, labor and capital. Next, types of production function. Production function. First we have is short run. Short run is a period of time where at least one factor is fixed. Usually we see that K is fixed, capital. In case of long run, all factors of production can be varied. All factors of production can be varied. Since all factors in this function are variable, so the output can be increased by changing input. So as input changes, the output also changes. A firm can change its scale of production. This is known as returns to scale. Next, we have level of production. Level of production can be altered by changing the proportion of our variable inputs. Output is basically what? Fixed input plus variable input. You can't change your fixed input, but you can change your variable input. So that's why we are saying that the level of production can be altered by changing the proportion of your variable input. Now, scale of production. Scale. This is about level. Your scale of production can be altered by changing the supply of all inputs in the long run. Change of supply of input in the long run. Let's say output is equal to total inputs, basically the variable inputs. Next, the concept of product. First we talk about product is total product. The total product is the total volume of goods produced in a specific period of time. Produced in a specific period of time. Second, average product. Average is sometimes also written as AVG, the per unit product of a variable factor. Then marginal product. When we used to talk about marginal price was when one additional good is increased. What happens? Marginal increase in or decrease in. So the rate at which total product TP increases or decreases from a unit increase in quantity of variable factor. Now let's see the formulas. The total product is given as Q is equal to the function of L. Why? because the capital is kept as fixed or constant that we are seen in the short run. This is the short run. MPL, marginal product, is seen as delta TP upon delta L, the change in the total product upon the change in labor. The average product is referred to as total product upon L. Now there is one more formula which says elasticity, output elasticity of production. Output elasticity. इसको हम we also say it as production is delta Q by Q upon delta L by L. So therefore delta Q by Q into L by delta L, which is basically MPL upon APL. Next. These are the formulas. This you need to keep in mind for solving all the numerical part. Numerical formulas. Now there are some assumptions when we say in the short run that amount of some factors are fixed. Assumption. First assumption is amount of some factors are fixed. Next, given technique of production. Technique of production. Homogeneity of factor units. What do you mean by homogeneity? Alike. Heterogeneity means which are not alike. Then availability of factors in small units. Then no change in price of factors of production. Then short period is our assumption, and also scarcity of resources. According to Benham, as the proportion of one factor in combination with other factor increases, after a point, first the marginal, then the average product of the factor will diminish. So, as proportion of one with respect to another increases, so what will first decrease or diminish? The marginal product will diminish, then the average product of factor will diminish. Diminish is basically decrease. Now let's see the graphs. These are very important graphs. I'll have to change them. I have to do two separate graphs. One is this and one is this. Here we need negative axis also. This is for total product versus labor x, y. So here we see that it increases in this form, and marginal product and average product graph will be seen here in the form of now see, this is the graph of AP, this is graph of MP, and this is graph of TP with respect to labor only. So here, what we say till here, from this point, then till the highest point where MP is 0. Now, this is divided into stages. So this is stage 1, this is stage 2, and this is stage 3. So now, TP curve here increases till point G, and then at a decreasing rate. Till here it is increasing at a increasing rate, then at a decreasing rate. So this point is known as the point of inflection. Here the MPL is increasing. As you can see, the MPL is increasing in this portion. MPL is increasing. Here the MPL is positive and here MPL is negative. So in the stage 1, we see that the total product is increasing at an increasing rate. In stage 2, we see that the TP continues to increase but at a decreasing rate and reaches the maximum point. This maximum point, here MP starts declining now. As you can see, MP starts declining here. I'm drawing with the dotted line if you can see. Let's use a pointer. So see here MP is decreasing. This stage is known as the law of variable proportions. It states that with the increase of quantity of the variable factor, other factors are fixed. Its marginal product and average product will start decreasing or declining. Can you see it's gradually declining after the stage is declining, it's declining. Here it is assumed that each worker, this assumption is very important, assume each worker has each labor has same skill set. In stage 3, we can see that after reaching the maximum total product, in stage 3, the TPL starts declining now. This part starts declining and MPL starts becoming negative. So now let's see optimal use. Now let's do the next topic. So the next topic is optimal use of variable input. Marginal revenue product. Marginal revenue product for labor is given as the marginal product of labor multiplied by the marginal revenue. Revenue, just remember P into Q. I remember it by P into Q. P is price. Price is your revenue. Q is your marginal product. Like this. Just remember it in this way. It will be easier to understand also. Then after that, marginal resource cost of labor is delta TC by delta L. And we have optimal use. When do we have optimal use? When your marginal revenue product of labor is equal to your marginal revenue cost of labor, resource cost of labor. That means the cost is being covered at this point. So let's see. So basically, this is the graph. Here we have MRCL. MRCL remains constant as $20. So now when we draw a MRPL, so see MRPL. At this point, your MRCL is equal to your MRPL, units of labor used. So next now, isoquants. Isoquants and isocost. So iso is derived from the Greek word equal, and isoquant means equal quantity. This curve shows that all technological combinations, the curve is like this. Here we have a set of numbers like 1, 2, 3, 4, 5, 6. This represents K. And here we have 1, 2, 3, 4, 5, 6, L. Now when you see here certain values are there and we are getting the same amount of value, and when we draw the curve we'll get this form of a curve. This is known as your isoquant curve. So properties are that it is downward sloping. Higher the higher isoquant, the higher is the output. It is convex to origin. And your last point is that it never intersects, never intersects. So these are the properties. So basically you can have function like 12q, 28q, here 36q and here 40q. Now let's understand economic regions of production. So here I'll take a different pen, green. So we'll divide it in this form where and we'll divide it from here. Now as we can see, we have drawn these lines. These lines are called as ridge line. Firm will use the combinations of the two inputs that are in the economic region of production, which is defined by the region, that is use combo, where portion of each isoquant is negatively sloped. So now here we can say that this is stage 1, inside it is stage 2, and here is stage 3. Now let's understand this with the help of a yellow pen. So now in stage 1, as labor increases, it's not visible. Let's see. Labor increases. So does capital decreases? Increases. So as labor increases, the capital also increases. So this area is called positively sloped. In the second region, it is the economic region which we were talking about. Economic region of production where all the production takes place. Why? Because this area is negatively sloped as we had talked about here. So there's one formula, marginal rate of technical substitution, MRTS. We'll cover it in the next slide. Wait. So let's see. Marginal rate of technical substitution. So what is marginal rate of technical substitution? It gives us the relation which is mostly used in our numericals. That is MRTS is equal to minus MPL upon MPK is equal to dk by dl. What basically we write MPL upon MPK is equal to W by R. We'll discuss about this later on when we solve the numericals also. In numericals, basically you have to calculate MPL, MPK. You will be given your functions in form of K, L, and W and R would be given, and you'll have to check or find the values. So we'll do these numericals later on. So MRTS dk by dl is also written as delta k by delta l. So the absolute value of the slope of isoquant is called MRTS. Isoquant curve, this curve. So let's see. Production with two variable inputs. We'll cover it here only. First is we have perfect substitute and perfect complements. There are two separate graphs that we'll have to draw. Wait. Complements. Substitutes. In case of perfect substitute, we have graph like this. In case of a perfect complement, we have L's like this. Or we can say a step-shaped graph. So this is graph for perfect substitute and complement. These can be asked as a 1 mark for questions. So next we see optimal combinations of inputs. Optimal combination of inputs. In this isocost line represent all combos. Combo basically combinations of two inputs that a firm can purchase with same total cost. And your equation is C is equal to WL plus RK, where C is your total cost, W is your wage rate of labor, and R is your W for labor, and R is for capital. For cost, here wage difference. Now it can also be written as C by R minus W by R into L. So slope is equal to, you can write here, slope is equal to minus W by R. Let's see this line. This is the line, so vertical intercept, and this is the slope. Now in the graph, let's see the graph carefully. So this was the Isoquant graph that we have been drawing till now. This line that we have drawn right now, you may not be understanding it right now. I'll tell you. Just wait. Let me finish though. Assume this point to be here, touching here, and similarly a line that goes through here and touches the x-axis. So this line, the line that we have drawn here, I'll make it with black. This is known as the expansion path. Now, in expansion path, one thing that we have to know is this line. This line, what we are seeing, this is what? This we had studied in the previous slide. This is your isocost line. An expansion path, we'll write it down here. Expansion path is the locus of producer's equilibrium by points of tangency of successive isoquants with corresponding isocost line. So this basically is explaining that it is a locus, a tangent to a parabola. What is it like? Like this. So basically it is the locus of the producer's equilibrium by the points of tangency where successive isoquants with corresponding isocost lines meet. So this MRTS has to be equal to W by R. So therefore we got the relation that we were talking about earlier. MRTS is equal to MPL upon MPK is equal to W by R. Now what if I say MPL upon W is greater than MPK upon R? That means that it is not working efficiently. Or in what is the correct thing to write is it is not a optimal combination that we are doing. It is not in optimal combination. So optimal combination is when the slope, optimal combo is when slope of isoquant is equal to slope of isocost line. So by that we get MRTS with this formula. Now what is returns to scale? Returns to scale refers to the degree by which the output changes as a result of a given change in quantity of all inputs used in production. Let's understand them easily. So we are talking about long run at the moment. Long run. In long run, we increase L, we increase K, then by what scale will Q change or have an impact on production? This is what is your returns to scale in easy language. This is what is returns to scale. Now we have three things here. First of all, let's see this. Q is equal to FL comma K. We had covered this earlier. If your lambda is equal to H, then constant, lambda greater than H increasing, lambda less than H decreasing. So let's see. Now I'm drawing three graphs. 1, 2, 3. Now here we see 100Q, 200Q. Here we can see that it is increasing 100 to 200. Now let's see the second one. Yes. This is your 100 to 300. This is increasing from 100 to 150. And this is your expansion path. So K, L, K, L, K, L. So this graph is known as constant returns to scale. 2 into. Now more than 2 into increasing returns to scale. And here it is less than into 2. So decreasing returns to scale. To scale. Now next we have Cobb-Douglas production function. Cobb-Douglas production function. Cobb-Douglas production function is Q is equal to A, K to A, L to the power B. So your Q dash, if we double Q and L, so what will we get? Let's say, so 2K and 2L, therefore 2K to the power A and 2L to the power B. You take them out, 2A, KA, 2B, LB. So you get 2 to the power A plus B, aka LB is equal to 2A plus B Q. So this is a very important relation. 2A plus B Q. When your A plus B is equal to 1, that means constant returns to scale. When your A plus B is greater than 1, increasing returns to scale. When your A plus B is less than 1, decreasing returns to scale. So now we have one last topic, that is economies of scale and diseconomies of scale. Economies of scale and diseconomies of scale. So now in economies of scale, we talk about technology, cost effective at higher level of production, and specialization of labor. We'll study about this more when we study cost. What is the role? Transportation cost and difficult to manage. Right now it may be unclear, but when we'll understand it later, it will be easier for you. So this is all for today, where we covered production, short run, long run production, graph, isoquant, isocost line, what is marginal rate of technical substitution. So if you like the video, do like, share, subscribe, and if you have any doubt, please feel free to write in the comment section. So thank you. Bye bye.